Today we will discuss about applications of solar energy. The solar technologies are broadly categorized as either passive solar or active solar depending on the way they capture, convert and distribute solar energy. The active solar techniques they include the use of photovoltaic panels, solar thermal collectors to harness the energy. And passive solar techniques they include orienting a building to the sun, then selecting materials with favorable thermal mass or light dispersing properties and designing spaces that naturally circulate air. So active solar technologies increase the supply of energy and are considered supply side technology. And with passive solar technologies, they reduce the need for alternate resources and are generally considered demand side technology. The partial list of solar applications, they include space heating and cooling through solar architecture. Here's a similar thing which we studied in the orientation of building. Then portable water via distillation and disinfection, daylighting, solar hot water, solar cooking, high temperature process heat, industrial purposes. To harvest solar energy, the most common way is to use solar panels, very much common for producing electricity using solar energy. So we have covered this topic in another lecture. So I will share the link of that video in the description box. Okay, now some of the applications like the horticulture and horticulture. Then, sorry, in agriculture and horticulture. So agriculture and horticulture seek to optimize the uh, capture of solar energy in order to optimize the productivity of plants. So which type of effect we are dealing here? Okay, light is there, yes, because photosynthesis that only occurs in the presence of light. But another thing that is the heat. Okay, heat we are trying to optimize. So we are trying to trap the heat. So application of solar energy in agriculture aside from growing crops. So other applications include water pumping, drying of crops, brooding chicks, drying chicken manure. So there are a number of applications where solar energy finds use, is being used. Okay, now the greenhouse effect. So why the glass in the picture shown there, the glass is they are covered over the plantation. So they are trying to capture the heat. So what is the beauty of this glass that it allows the heat to enter, but it doesn't allow the heat to leave. Okay, so in this case, the greenhouse effect means the heat that is trapped and the crops which are not able to survive in a cold climate, relatively cold climate as per their natural habitat. So they can survive here in the glass greenhouse beneath this glass covering because here the temperature is more. They're trapping the heat. Okay, day lighting. So the name indicates day and lighting means the sunlight we are utilizing for lighting purpose of some type of our building or any other establishment. The daylighting system collect and distribute sunlight to provide interior illumination. The hybrid solar lighting is an active solar method of providing interior illumination. Okay, so interior, we can light our building using this solar energy, solar sunlight indirectly we can say. So solar thermal technologies can be used for water heating, space cooling, process heat generator. Okay, some other applications where we are using solar energy or the heat in the solar energy. Okay, on the other hand, cooling as well. So solar hot water systems use sunlight to heat water, something similar which we have seen in the collector section in our previous video. Then next application is water treatment. So solar distillation can be used to make saline or brackish water potable. So how? Because solar water disinfection involves exposing water-filled plastic polyethylene terephthalate bottles to sunlight for several hours. Solar energy may be used in water stabilization pond to create wastewater without chemicals or electricity. Means we are not using energy, any other means. Sunlight, solar energy we are using for water stabilization pond. Okay, so we are treating wastewater. Next application, cooking. So household, even in households, we can use this type of application of solar cooking. So solar cookers, they use sunlight for cooking. So drying, pasteurization. So they can be grouped into three broad categories: box cooker, then panel cooker, and reflector cooker. The box cooker consists of an insulated container with a transparent lid, similar to the glass effect. And panel cooker use a reflective panel to direct sunlight onto an insulated container and reach temperature comparable to the box cooker. So here they're using this type of reflective panel that is diverting and concentrating the sunlight to the insulating container where our item to be cooked that is placed. So reflector cooker use various concentrating geometries, okay, like the dish, straw, and Fresnel mirrors. So they're focusing the light on the container where the cooking item that is being placed there in the container. Next thing is process heat. So something related to industrial applications as well. So solar concentrating technologies, such as the parabolic dish, Atrov, and Scheffler reflectors, they can provide process heat for commercial and industrial applications with large scale and huge amount of heat we can produce using this type of applications, this type of technologies, the concentrators. Okay, parabolic dish trough or Scheffler reflector. The evaporation ponds are shallow pools that concentrate dissolved solids through evaporation. The clotheslines, clothes stores, clothes racks, they're drying the clothes by evaporating by wind and sunlight. So not using gas or electricity for drying of clothes. The very common application, this is photovoltaic. Photo mean light to voltaic, electricity generation, direct conversion from light to electricity using solar cells or solar panels. Okay, this we have discussed in detail. I will share the link in the description. You can follow that. Experimental solar power. So here we are having a solar pond. Okay, that is a pool of water 1 to 2 meter deep, and it is collecting and storing solar energy. Means we are storing the solar energy using a solar pond. So solar pond, it is having layers of water that successively increase from weak salt solution at the top to high salt solution at the bottom. Means the concentration of salt that's in the solution that is increasing as per the depth. So this solar pond is capable of producing temperature of 90 degrees Celsius in its bottom layer, means the lowest layer, and had an estimated solar to electric efficiency of 2%. So thermoelectric or thermovoltaic devices convert the temperature difference between dissimilar metals into electric current. Using this type of storage, we can produce current. We can store solar energy and in the form of heat, and we can produce electricity. Now, solar chemical. So solar chemical processes use solar energy to drive chemical reactions. So these processes offset energy that would otherwise come from an alternate source. Okay, some type of fuel will be using. Okay, now we don't need storable and transportable fuels we can obtain. So some of these processes, like the one very common, that is hydrogen production and the process of steam reformation of natural gas, of methane. So we have also discussed this topic in another lecture in detail, and I will share the link with there also, how natural gas can be used for producing hydrogen using the steam methane or steam natural gas reforming. Okay, so these chemical reactions can be thermochemical or photochemical, means both properties, heat and light, we can utilize for producing some type of chemical. Okay, like here the hydrogen we are producing. The thermochemical cycles characterized by the decomposition and regeneration of reactants present another avenue for hydrogen production. With the solar vehicles having a huge scope in the near future, so they are using solar panels for auxiliary power. Okay, like for air conditioning, to keep the interior cool and reducing the fuel consumption, because the AC is there, they are using the fuel for cooling. Again, a solar balloon, that is a black balloon, it is filled with ordinary air. So solar sails are proposed form of spacecraft propulsion using large membrane mirrors to exploit radiation exposure from the sun. Now medical uses. We can the medical use mainly that is being studied here, that is for ultraviolet light in the sun. So the medical uses include disinfection, sterilization without the use of chemicals. Like ultraviolet, it is destroying some not all, but some bacteria and viruses. It stimulates the immune system and has shown good results in lacking blood-borne pathogens. So the next is the ultraviolet light. It can also be combined with other therapies. So some type of skin infections also can improve with the exposure to ultraviolet light. So some of the microorganisms which are destroyed by ultraviolet light, so they are like Bacillus anthracis, Salmonella for food poisoning, Shigella dysentery causes dysentery, then bacteriophage, that is E. coli, the short we call as E. coli, hepatitis and influenza.